Hello everyone, this is Dr. M. Shankar, Assistant Professor, Department of Statistics. Your subject name is Statistical Methods for Computer Applications 1 and your subject code is 19ASCS 31. In this video, we are going to discuss about Unit 4 Probability, basic definitions and examples. The first definition is random experiment. An experiment conducted under identical condition, outcomes is not unique but may be any one of the possible outcomes, then such an experiment is called random experiment. Example, tossing a coin is a random experiment. We get the result head and tail. Another example, throwing a die is a random experiment. We get the result 1, 2, 3, 4, 5 and 6. Next one is outcomes. The result of random experiment is called outcomes. Example, tossing a coin is a random experiment. We get the outcomes head and tail. Throwing a die is a random experiment. We get the outcomes 1, 2, 3, 4, 5 and 6. Then third one is trial and event. Each performance in a random experiment is called trial and their outcomes are event. Example, from a pack of cards drawing, any two cards is a trial and getting a king or queen are events. The next one is exhaustive event. The total number of possible outcome of a random experiment is known as exhaustive event. Example, in tossing a coin, we get head and tail. Therefore, we have two exhaustive events. Likewise, in throwing a die, we get the possible outcomes 1, 2, 3, 4, 5, 6. Therefore, we have 6 exhaustive events. The another definition is favorable events. The events which favorable to our object of the study are called favorable events. Example, in throwing a die, we get 1, 2, 3, 4, 5 and 6. Our favorable event is getting even numbers only. 2, 4 and 6 are favorable events. And another favorable event is getting only odd numbers. We have 1, 3 and 5. This is our favorable events. Next example of favorable events. In throwing of 2 dice, the number of events favorable to getting the sum is 5. When throwing a 2 dice, we have the sample space 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6 and 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. These are our sample space of 2 dice is thrown. But our favorable events are getting sum is 5. Here 4, 1, 1, 4, 3, 2, 2, 3. The sum of values is 5. This is our favorable event. Next one is equally likely event. Two events are said to be equally likely if one of them cannot be expected in preference to the other. Example, equally likely events. In tossing a coin, head or tail are equally likely events. And another example, in drawing a card at random from a full pack of cards, each of the 52 cards is equally likely to appear. That is called equally likely events. Independent events. The several events are said to be independent if the happening of an event is not affected by the happening of the remaining events. In symbolic form, probability of A intersection B equal to probability of A into probability of B. Example, in tossing a coin, the events of getting a head in the first toss is independent. Likewise, getting head in the second toss and getting head in third toss and getting a head in fourth toss. All are independent. Next definition is mutually exclusive events. Two events are said to be mutually exclusive when the occurrence of the first event does not affect the occurrence of the second event. In other words, if A and B are mutually exclusive event, and if A happens, then B will not happen, and vice versa. In symbolic form, probability of A intersection B equal to probability of pi, that is equivalent to 0. Example, tossing a coin, the event of getting a head or tail are mutually exclusive since both head and tail cannot appear in the same time. Next definition is sample space. The set of all possible outcomes of the random experiment is called sample space. The sample space is denoted by capital S. Example, in tossing a coin, random experiment, we get the result head and tail or outcomes. The sample space is head and tail. Next one is the sample point. Each and every element of the sample space is called sample points. Example, in tossing a coin is a random experiment. We get the results head and tail, it's called outcomes. Each of the sample space is called sample point, that is head is a sample point and tail is also called as sample point. Next one is note. This is very useful to find the sample space and exhaustive event and result of tossing a coins. First, tossing one coin, we get the sample space head and tail, that is our exhaustive event is 2. Here 2 power 1 is nothing. 2 means 2 faces of coin and 1 means tossing a one single coin. We get 2 sample outpace. Tossing of 2 coins, we have the sample space head tail, tail head, head head, tail tail. That is the total number of exhaust cases 4. Here we denoted 2 power 2, that is equal to 4. Tossing 3 coins, we get the sample outcomes head head head, head head tail, head tail head, tail head head, tail tail head, tail head tail, head tail tail, tail tail tail. Our exhaustive event is n equal to 8. Here 2 power 3 means 2 faces, 3 coins is tossed. We get our outcomes is 8. Next note is likewise die. Throwing first die, we get the sample space 1, 2, 3, 4, 5 and 6. The total number of exhaust event is 6. Here throwing 2 dice, already we know that our sample space of 2 dice. Here we have the 36 sample outcomes. This is called as our sample space of 2 dice. Thank you. In this video, we have discussed about the basic definitions and examples of probability and some examples for how many coins are tossed, we get the possible outcomes, and how many dice are thrown, we get the possible outcomes. Also, we discussed in this video. Thank you all.